Solar energy is still a bit of a mystery to a lot of people in our network.
Let's do it.
With the right information, crews can grasp the specialized final steps of PV installation. This series has that information. Part 3 of the Home Energy Pro Solar Series will teach you the basics of connecting to the electrical grid. We'll teach you the steps of commissioning a PV system and monitoring output to ensure the job is done right. We're meeting up at a market rate home across town to commission a DC system to compare to the AC system we installed. The home and the PV components may differ, but the concepts are the same.
Sam, this house does not have microinverters like the house that we were installing on. AC is what we're using in the house. DC is what we're collecting from the sun. We got to transform it somehow.
Microinverter system happens right up on the roof. With the DC system, it happens at one string inverter that's located in the garage of this home. At this particular residence, we've got multiple subarrays on the roof. Those come together, harvesting all the electricity as DC, and then this machine converts that from DC to AC. This here is a bit more of a modern string inverter in that there are also electronics on the roof that allow the individual solar modules to operate while one of them is shaded. It's called DC to DC optimizers.
They attach to the rails and work a lot like microinverters to operate panels individually.
Typically, we find that the DC to DC optimized system might be less expensive in a particularly small installation.
Feeding power from the solar array to the home can be accomplished in various ways.
There's all kinds of different opportunities on where we can have what's called the point of interconnection. And in this situation, it just happens to be conveniently located on the side of the house. Other times it might be in a sub-panel inside of the home. At the side of this individual's residence, we have the AC disconnect, we have the electrical distribution, and then the utilities meter. There is energy flowing from the energy utility into the home's service, but also, since we have solar on the roof, there's energy that is flowing back feeding into this and then backwards to the grid.
There will be some form of disconnect on each system. An AC disconnect opens and closes the circuits between the inverter and the home's AC electrical supply.
It's a safety feature for a first responder. Fire department shows up, they need to be able to quickly turn the solar off. And here, we have a DC disconnect.
So on the inverter itself.
Yeah, so if you look below here, you'll see there's two particular pipes. So this actually contains the wiring that comes from the rooftop solar modules here into the inverter.
These disconnects are safety components which allow professionals to work on the system and cut off power in the event of emergency.
We ready to turn this on and commission the system?
Yeah, I think this would be a great opportunity.
Commissioning is the process of closing all disconnects and powering up the inverter or microinverters.
You want the honors?
I'm going to leave that one to you.
All right, sounds
So
good.
You're the professional. Do it.
The solar professional checks to ensure all components are working properly and producing power as expected.
A lot of this modern solar equipment is all connected to the internet. I'll be looking on my phone at the guts of the inverter. I'm just gonna scan a little QR code on the side. All right, so yeah, we can see here that the device is ready. I have to tell the inverter to talk to all the different electronics on the roof. The various power optimizers on the roof. I'm gonna go ahead and just run that pairing scenario. It's found four
of them.
Six, and it's just gonna continue to add through those. When you turn on a modern solar array, this thing's actually gonna make some clicking noises. It's gonna flip over and it's gonna start making electricity. 3, 2, 1.
There's the click.
So I can peep on my phone here and see that the system is getting going. Oh yeah, look at that, it's already up to 4.7 kilowatts, okay? So that's just the kind of thing we want to look for when we're first commissioning, is making sure we have an accurate power production. I can see here that this is connected to the home's internet. The internet monitoring is going to allow solar production information that this thing is sharing to be visible to the homeowner. Yeah, the system is operational.
Got some increased power output right now.
Most modern systems allow the client to monitor their own panels and inverters using the same or similar apps that a solar professional may use for commissioning.
This is our power today. Right now, 5.4 kilowatts is our current power. We've produced already about 28 kilowatt hours. You can keep track of what you're using and what you're pumping back into the grid.
When clients become part of the process, it reinforces the importance of energy use, and now, energy production. That's a wrap on our 3-part Home Energy Pro Solar Series. You've followed a home assessment, worked alongside a crew on a typical install, and even peeked behind the curtain at the final steps performed by electricians and solar pros. To see PV in practice, check out our profile, Solar Frontier, Low Income Solar in Colorado.